In this section, we will learn about a new coordinate system, which is called polar coordinate system. We've been using rectangular coordinate system. The rectangular coordinate system consists of x and y axis. If we have a point on the plane, then that point can be uniquely represented by x coordinate and y coordinate. In this particular case, the x coordinate is A and the y coordinate is B. Polar coordinate system consists of a pole and polar axis. If we embed the polar coordinate system in the rectangular coordinate system, then polar axis coincide with the positive x-axis and the pole coincide with the origin in the rectangular coordinate system. If we have a point on the polar coordinate system, then that point can be represented by r and theta. R is an oriented distance and theta is an angle between polar axis and the line segment which joins the pole and the point P. Polar axis is always an initial side of the angle. R is an oriented distance. R is positive if P is on the angle direction. In this picture, P was denoted by R and theta. This is the angle theta, and the point is on the angle direction. So in this case, R is positive. If we consider the angle which is denoted with green dotted line, then that angle is considered as the opposite of the angle theta. Angle measurement of that angle is, this is 180 degree, and those two angles are added, so opposite of angle theta is 180 degree plus theta. If we use this angle to represent point P, then we denote R as minus. So it becomes minus R, and the angle we are referring to will be theta plus 180 degree. For theta, initial side is polar axis. The terminal side is the line segment connecting that point and the point given. So in this case, we use the angle theta, but we can use other coterminal angles. For example, if we consider this angle as an angle whose initial side is the polar axis, then this angle can be denoted as theta plus 360 degrees. If we consider the point like that, then we denote the point as r and theta plus 360 degrees. If we use the radian measure notation, then we can say r and theta plus 2 pi. There are infinitely many notations for the given point, which was denoted by r and theta. Different from in the rectangular coordinate system, the way we denote the polar coordinate is not unique. Let's do some examples. In this problem, we want to plot the points, and we want to write two other polar coordinate representations, one with r positive and one with r minus. The first problem is 1, 3 pi over 4. When you plot this type of problem, the first thing you will do will be locate the angle. And then you will plot the point. When you plot the point, you have to observe whether r is positive or negative. If r is positive, then the point is located on the angle direction. When r is negative, the point is located opposite of the angle direction. In this problem, r is positive, so the point will be located toward the angle direction. Let's locate the angle first. This is pi. Pi can be written as 4 pi over 4. So angle is located in the second quadrant. This is angle 3 pi over 4. We have r equals 1, which is positive. So the desired point will be located on the angle direction. The distance between the origin and that point will be 1. Second part of the problem is listing the coordinate representation, polar coordinate representations when r is positive. In that case, we will use the coterminal angle. Then that'll become 1 and 3 pi over 4 plus 8 pi over 4. So that is 1 and 11 pi over 4. You can use 4 pi, or you can subtract 2 pi, and so on. There are many different answers, but all of them will be correct. We used the coterminal angle because the given angle is a given r is positive, and in this problem we are thinking about the same r. But if r is negative, then you have to think about the opposite angle. Opposite angle can be obtained by adding pi. So if we think about this angle, then that is pi plus 3 pi over 4, which is 7 pi over 4. Let's write it down. R is negative, so we switch the sign. Then we think about the opposite angle. 3 pi over 4 plus pi, then that is minus 1. 3 pi over 4 plus 4 pi over 4. So that is minus 1 and 7 pi over 4. In this problem, the polar coordinate is given as 3 and minus pi over 6. Let's locate minus pi over 6. Minus pi over 6 is located in the fourth quadrant. The angle is minus, so we go clockwise. This is minus pi over 6. Then we notice r is positive. Then the point is located on the terminal side of the angle. The distance between the origin and the point is 3. Let's consider other expression. When r is positive, we look at the problem, then r is given as positive, so we will copy it. And then we will consider the coterminal angle. Let's add 2 pi. Then that'll be minus pi over 6 plus 12 pi over 6. So that is 3 and 11 pi over 6. So this time we understand the angle differently, and it became 11 pi over 6. Both angles share the same initial side and the terminal side. If r should be minus, then we have to switch the sign of r, so it becomes minus 3. In that case, we have to think about the opposite angle. So we want to add pi here. So it becomes minus pi over 6 plus pi. Then that becomes minus 3 and minus pi over 6 plus 6 pi over 6. So that is minus 3 and 5 pi over 6. So this angle is 5 pi over 6. The next problem is 3 and 3 pi. Let's locate the angle. This is pi, this is 2 pi, this is 3 pi. R is 3, and so R is positive. So the point is located on the terminal side of the angle, and the distance between the origin and the point is 3. When R is positive, they will have same R, so 3 comma, and then we will think about the different angle expression for this angle. Then we don't have to calculate it. That is pi. It could be minus pi, or it could be 5 pi, and so on. You can write any of them. When R is negative, the point is opposite of the opposite angle. So this angle is angle 0, 2 pi, negative 2 pi, and so on. But R must be negative, so minus 3 and 0, or minus 3, 2 pi, or you can write minus 3 minus 2 pi. There are infinitely many correct answers. In this problem, we have a polar coordinate minus 4 and pi over 4. Let's locate the angle first. Pi over 4 is in the first quadrant. But R is negative, so instead of locating the point on the terminal side of the angle, we go opposite. The distance is 4. But in this case, we denote it as minus 4. Let's figure out another expression when R is positive. This time, we are changing the sign of R. We have to write 4, and then the point must be on the terminal side of the angle. that means we have to calculate this angle. We have to go pi more to obtain that angle, so this angle will be pi over 4 plus pi. So that is pi over 4 plus 4 pi over 4, and that is 4 and 5 pi over 4. If r is negative, then we copy it down here, and we think about the coterminal angle of pi over 4. So we add 2 pi, then it becomes minus 4 and pi over 4 plus 8 pi over 4. So that is minus 4 and 9 pi over 4. We've been locating the polar coordinate system in the rectangular coordinate system. So when we have a point on the plane, we can express that point with polar coordinate and rectangular coordinate. We want to figure out the relationship between polar and rectangular coordinate. Let's suppose that this point polar coordinate is r and theta. Then when we draw the right triangle, this side length is y and this side length is x. By using the Pythagorean formula, we can say that r squared is x squared plus y squared. We consider the coordinate definition of the trigonometric function. Then cosine of theta is x over r, and sine of theta is y over r, and tangent of theta equals y over x when x is not equal to 0. We want to compare the polar coordinate and rectangular coordinate, so we want to express x with r and theta. To do that, we will multiply by r on both sides. Then x is r cosine of theta. We do the similar, then y can be expressed as r sine of theta. This gives us the formula which convert the polar coordinate to rectangular coordinate. And when you convert the rectangular coordinate to polar coordinate, we use these two formula. Let me summarize. Change from polar to rectangular coordinate. That is obtained by x equals r cosine of theta and y equals r sine of theta. If we want to change from rectangular to polar coordinate, we use the Pythagorean formula r squared equals x squared plus y squared. And then we take square root on both sides to get an r. To figure out the angle, we will use inverse tangent function. So to do that, we will use tangent of theta equals y over x. In this problem, we want to convert the polar coordinate for 2 pi over 3 to rectangular coordinate. This is a polar coordinate, so r is given as 4 and the angle theta is given as 2 pi over 3. Angle theta 2 pi over 3 is located in the second quadrant. And r is positive. So the point is located on the terminal side of the angle. We want to convert that to the rectangular coordinate system, so we express x as r times cosine of theta. So it becomes r, which is 4 times cosine of 2 pi over 3. We want to use the reference angle to evaluate it. The reference angle is the difference between 3 pi over 3 and 2 pi over 3, which is pi over 3. And then in the second quadrant, cosine is negative because x is negative. So we put minus here. So 4 times cosine of pi over 3. So that is minus 4 times 1 over 2, which is minus 2. And y equals r times sine of theta. We do similar reasoning. R is 4 and sine of 2 pi over 3. This time, sine is positive because y is positive in the second quadrant. So that is 4 times sine of pi over 3. So that is 4 times square root of 3 over 2. When we simplify, we get 2 square root of 3. So we got x and y. The final answer will be minus 2 and square root of 2 square root of 3. In this problem, we want to convert the rectangular coordinate to polar coordinate. The rectangular coordinate is given as 7 square root of 3 minus 7. Let's locate the angle in the quadrant. X value is 7 square root of 3 and y value is minus 7. So that is the point. 7 square root of 3 and minus 7. To consider the polar coordinate, we have to know r and theta. Let's calculate the distance between the origin and that point. That was r squared equals x squared plus y squared. X was 7 square root of 3 squared plus y was minus 7, so y squared is minus 7 squared. Then the first number becomes 147 and the second number is 49. If we add them up, then that is 196. To calculate r, we have to square root on both sides. So we calculate square root of 196. That equals 14. Let's consider tangent of theta. Tangent of theta is y over x. Y is minus 7 and x is 7 square root of 3. So these two will cancel each other and we have minus 1 over square root of 3. One is opposite and square root of 3 is adjacent in the reference triangle. If you consider 30, 60, 90 degree triangle, then 1 is opposite to the angle pi over 6. So we have reference angle for the angle theta, that is pi over 6. The angle is in the fourth quadrant, so by using that reference angle, we can say that that is minus pi over 6. If you don't like the negative angle, then you can consider this angle. This angle is 11 pi over 6. You can add 2 pi to minus pi over 6, or you can figure that out by thinking 11 pi over 6 plus pi over 6 will be 12 pi over 6, which is 2 pi. So, as usual, there are many answers. 14 minus pi over 6 is one of the answers. But you can write 14 and 11 pi over 6. There are infinitely many answers. Now we want to discuss polar equations. We want to express x squared equals 4y in polar coordinates. We will use the formula x equals r cosine of theta and y equals r sine of theta. Then on the left side, x squared is r squared times cosine squared of theta. On the right side, we have 4 times y was r, sine of theta. We want to simplify the equation by dividing by r on both sides. Then the left side will be r cosine squared of theta equals 4 sine of theta. We want to solve for r for the polar equation. To do that, we will divide by cosine squared on both sides. Then on the left side is r and right side is 4 times sine of theta over cosine of theta times cosine of theta. So r equals 4, we can rewrite that as 4 over cosine of theta times sine theta over cosine of theta. Then this part becomes tangent of theta, and we want to express 1 over cosine theta as secant of theta. So let's rewrite that as 4 times 1 over cosine of theta times tangent of theta. So r is 4 times secant of theta times tangent of theta. This is the final answer. In the next example, we want to express the polar equation in rectangular coordinate, and then we want to consider the geometric property. Express the polar equation in rectangular coordinates. If possible, determine the graph of equation from its rectangular form. The first problem is r equals 5 secant of theta. This is a polar equation, and to make that in rectangular equation, what we would consider is the relationship x equals r cosine of theta and y equals r sine of theta. The given equation r equals 5 secant of theta can be rewritten as r, which was r equals 5 times 1 over cosine of theta. If you multiply cosine of theta on both sides, then you can combine r and cosine of theta, and then you can write it as x. Let's multiply cosine of theta on both sides. Then left side becomes r cosine of theta, and right side becomes 5. So r cosine of theta equals 5. The r cosine of theta equals x. So the given equation becomes x equals 5. This is 5. This is x equals 5. So this equation is indeed a vertical line. The second equation is r equals sine 2 sine of theta. What we will use again will be x equals r cosine of theta and y equals r sine of theta. But in this equation, if you divide by sine theta on both sides, then r and sine will be combined, but those will not be combined as a multiplication form. So we will multiply by r on both sides. Then left side becomes r times r, and right side will become r 2r sine of theta. So left side becomes r squared, and right side is 2r sine of theta. We want to relate that with the rectangular coordinate system. So another relationship we want to use is r squared equals x squared plus y squared. So r squared is x squared plus y squared on the left side, and on the right side we have 2 times y. To finish the problem, is what we do is x squared plus y squared minus 2y. That equals 0. We moved 2y to the left side, and then what we will do will be completing the square. The number we have to add on both sides will be the half of the number in front of y squared. Then we get x squared plus y minus 1 squared equals 1 squared. If you cannot convince yourself about that, then you will write y squared, y minus 1 squared as y minus 1 times y minus 1, and then do FOIL, then you will get y squared minus y minus y plus 1, which is 1 squared, y squared minus 2y plus 1 squared. That is the same as this part. So we did it correct. Indeed, that is the equation of a circle. Circle with radius 1 and center 0 and 1. If we visualize, then center is 1 and the radius is 1. This is r equals 2 sine of theta in a rectangular coordinate form, that is x squared plus y minus 1 squared equals 1 squared. The angle theta is pi over 2, and we want to convert that to the rectangular equation. In this case, we cannot multiply r. We have to have r cosine of theta or r sine of theta. Let's try to take cosine on both sides. Then the given equation becomes cosine of theta equals cosine of pi over 2. Cosine of pi over 2 is 0, and the left side is cosine of theta. So, to convert that into the rectangular coordinate system, we will use either x equals r cosine of theta or y equals r sine of theta. So we multiply by r on both sides, then we have r cosine of theta equals r times theta. r times 0. So this becomes 0. So left side is x and right side is 0. So the desired equation is x equals 0. Indeed, that is a vertical line which represents the y-axis. Let's consider taking sine on both sides for the given problem and see what happens. Then we have sine of theta equals sine of pi over 2. So given equation is sine of theta equals 1. To use this relationship, we have to multiply by r on both sides to get y, because we are converting the polar equation into the rectangular equation. So we have r sine of theta equals r by multiplying by r on both sides. Then the left side becomes y and right side becomes r. And then we realize that we cannot remove r from the right side. But we have to convert the polar equation into the rectangular equation, which means we have to remove theta and r in the equation. But we cannot remove r, so even if we take sine on both sides, we cannot get to the conclusion. So we have to abolish that idea. So that's the reason we take cosine on both sides.